Hello students, today's first question is, last year in a group of 30 businesses, 21 reported a net profit and 15 had investments in foreign markets. How many of the businesses did not report a net profit nor investment in foreign markets last year? So let us suppose, let X be the number of businesses which reported net profit and also had investments in foreign markets. So basically we have which are having both the features. Let us suppose that be X. Now let us draw a Venn diagram. Now let this circle represents profit and this circle represents foreign investments. Fine. So we have supposed that this is X. Right? Now since it says that 21 reported a net profit, so net profit will be, so if this is X, so this will be 21 minus X. So as to add 21 minus X plus X, X and X will get cancelled, so 21 will having profit. Right? And 15 had investments in foreign markets. So I will write this portion to be 15 minus X. Right? So 15 minus X plus X will give me the foreign investments, and X is the number which reported net profit as well as foreign investments both. Right? Now since there are total 30 businesses, right? So total of this will be 21 minus X plus X plus 15 minus X. Right? Now X and X gets cancelled, so this will be 21 36 minus X. Right? Now since there are total 30 businesses, so 30 minus this will be 30 minus 36 minus X. So opening the brackets, 30 minus 36 plus X. So this is basically equal to X minus 6. So X minus 6 will be the number that had no net profit. So this is over here, no profit as well as no foreign investment. So this region is represented by X minus X. So we have been asked to find how many of the business did not report a net profit nor investment in the foreign markets last year. So basically we need to find X minus 6, or in other words I can say we need to find the value of X. Right? Now with this information we will move to statement 1. Now statement 1 tells me that last year 12 of the 30 businesses reported a net profit and had investments in foreign markets. So what is this basically 12? So 12 is basically which is having net profit and also investments in foreign markets. So this is basically X. He is giving us the value of X. So if I have found the value of X, I can easily find X minus 6. So I will say that statement A is sufficient to answer my question alone. Right? Now moving to statement 2. Statement 2 tells me last year 24 of the 30 businesses reported a net profit or invested in foreign markets or both. So what does that mean? This means basically that this 24 is reported a net profit or investment in foreign markets or both. So that is basically this 21 minus X plus 15 minus X. So we have calculated this to be equal to 36 minus X. Right? So I can write that 36 minus X because this is which reported profit or foreign investments or both. Right? So adding, I got 36 minus X equal to 24. From here shifting X to other side, I will get the value of X equal to 12. So again I am able to get the value of X. So I will say that statement B is also sufficient to answer my question. So for this particular question, since both the statements alone are sufficient, the right option will be option D, that both the statements alone are sufficient to answer the question. Is the perimeter of sphere S greater than the perimeter of equilateral triangle T? So we need to find whether the perimeter of sphere S is greater than the perimeter of equilateral triangle T. So for this, let us suppose S represents side of sphere, right? And T, this is an equilateral triangle, so T represents side of equilateral triangle, right? Now we know that perimeter of a sphere is equal to 4 into S, 4 into side, and perimeter of equilateral triangle is equal to 3 into t, since we have let that psi to be t, right? So we have been asked that whether the perimeter of square is greater than the perimeter of equilateral triangle. So basically that means 4s is greater than 3t, or in other words I can say, if I shift 4 to other side, since it is positive, so it will not affect the sign of equality. So s is greater than 3 by 4 of t. So I need to find this basically, right? Or I can say s by t ratio is greater than 3 by 4. So any of these is sufficient to answer my question. Now with this information, we'll move to statement 1. Statement 1 tells me that the ratio of the length of a side of S to the ratio of a side of T is 4 by 5. So basically it has been given S by T is equal to 4 by 5. Now we need to find whether S by T is greater than 3 by 4. Right? So since 4 by 5 is greater than 3 by 4, right? So I can easily say that S by T, since S by T is 4 by 5 and 4 by 5 is greater than 3 by 5, so I can easily say that yes, S by T is greater than 3 by 4. So a sheer yes. So I can say that statement A alone is sufficient to answer my question. Right? Now moving to statement 2. Statement 2 tells me the sum of the length of a side of S and a side of T is 18. So what does that basically mean? This means that the sum of one of the sides of square and side of T is 18. So I have been given that S plus T is equal to 18. Now there can be different scenarios for this. Let us suppose S to be 9 and T to be 9, which adds up to give us 18. So in this case, S by T will be equal to 1. And since then in this case numerator is less than 1 and this is 1, so I can easily say that S by T is greater than 3 by 4. Right? But if I take the value of S to be, let us suppose 3 and this to be 15. So this also adds up to be 18. And now in this case S by T is equal to 3 by 5, which is equal to 3 by 15, which is equal to 1 by 5. Right? So now 3 by 4 is basically what? 3 by 4 is 0.75, right? And 1 by 5 is 0.20. So in this case I can say that S by T is less than 3 by 4. So I am getting yes, as well as so here I am getting yes, here I am getting no. So this is may or may not be condition. So I will say that statement B is not sufficient to answer my question, right? So for this particular question I will mark option A, that statement 1 alone is sufficient to answer my question. If x plus y plus z is greater than 0, is z greater than 1? So we have been given that x plus y plus z is greater than 0. We need to find that whether is z is greater than 1, right? Now with this information we'll move to statement 1. Statement 1 tells me that z is greater than x plus y plus 1, right? So z is greater than x plus y plus 1. And we have one more inequality from the main statement that x plus y plus z is greater than 0, right? We need to find z is greater than 1 or not. Now, since x plus y plus z is greater than 0, this means that z is shifting other two to other side. So this will be z is greater than minus common and bracket x plus y, right? Now, here I have been given that z is greater than x plus y plus 1. So if I add these inequalities, I will be getting 2z greater than, so minus of x plus y, and here it is x plus y, so it will get cancelled and I would be left with 1 only. So this implies 2z is greater than 1. Or I can say that z is greater than 1 by 2, right? Now z is greater than 1 by 2, so it can have any value, integer as well as non-integer, and I can't say surely that if z is greater than 1 or not. So let us take some examples for this. Now let us suppose that x equal to y equal to 0, right? And z equal to 2. Now first I have to abide by this inequality that x plus y plus z is greater than 0. So x plus y, so this is basically 0 plus 0 plus 2, which is 2, which is greater than 0, right? Now the second inequality is z is greater than, so z has to be greater than 0 plus 0 plus 1, so z is greater than 1. So z is value is 2, so it is greater than 1, fine. Now since z is greater than 1, and we are getting the value as z is greater than 1 by 2. So I can say that yes, z is greater than 1. But if I take some other example for this, let us suppose x equal to y equal to minus 1 by 4, right? And z to be equal to 3 by 4. Now, this x equal to y equal to minus 1 by 4. So from here I can see that when I add this, so this becomes minus 1 by 4 plus minus 1 by 4 plus 3 by 4 has to be greater than 0. So LCM is 4. So this is minus 1 plus 3. So this is basically 3 minus 2. So this is 1 by 4, right? And 1 by 4 is greater than 0. No, it is not greater than 0. So z can have value between 1 by 2 to 1, in which case that z is not greater than 1, or in this specific case where z is greater than 1. So I am getting may or may not be condition. So I will say that statement A is not sufficient to answer my question, right? Simply by having this, that z is greater than 1 by 2, I can't answer the question that whether z is greater than 1 or not, right? Now moving to statement 2. Statement 2 tells me that x plus y plus 1 is less than 0. So x plus y plus 1 is less than 0. And second inequality is x plus y plus z is greater than 0, right? Now again I have deduced this from this, so z is greater than minus of x plus y, right? Now this statement tells me that it is given that x plus y plus 1 is less than 0, or I can say x plus y, shifting this to other sides, is less than minus 1. Or if I multiply both sides by minus 1, then sign of inequality will change, but I will get over here minus of x plus y greater than 1, right? Now see, minus of x plus y, why I multiplied it by minus 1? So as to get this right side of this inequality. Now here it says that z is greater than minus of x plus y, but here it also says that minus of x plus y is greater than 1. So what we deduce from these two inequalities is that z is greater than 1, right? Because the value of z is greater than minus of x plus y, and minus of x plus y value is greater than 1. So z has to be greater than 1. So I can say that statement B alone is sufficient to answer my question. So for this particular question I will say that statement B alone is sufficient. But here I was getting z greater than 1 by 2. So it can have any value from 1 by 2 to 1 or greater than 1. So I am getting both the options, but here I am concretely getting the answer that z is greater than 1. So statement B alone is sufficient to answer my question. For all z denotes, so for all values of z, this z denotes basically the least integer greater than or equal to z, right? So least integer greater than or equal to z. So we need to find whether x is equal to 0. Now we will first use some examples for this. So let us suppose the value is minus 1.1, right? So this operation, let us call this bracket operation, tells us that the least integer greater than or equal to 1. So the value of this will be equal to minus 1, right? Because this is the integer which is greater than minus 1.1, right? Now let us suppose the value of x to be minus 1. So in this case it will be equal to directly minus 1. Least integer greater than or equal to, in this case greater than this is minus 1, and this, since it is equal to minus 1, so equal to minus 1. Now if I take the value minus 0.9, now in this case the greatest integer greater than or equal to minus 0.9 will be 0, right? If I take another example, let it be minus 0.1, so again it will be 0. For 0 it will be equal to 0, and for plus 0.1 it will be equal to 1, because now greatest integer is 1. So from these examples I can deduce that is x equal to 0. Basically I need to find that whether x is greater than minus 1, less than equal to 0, right? See, as it is minus 1, its value is minus 1, but as it reduces the value from minus 1 to minus 0.9, it is equal to 0, right? And up to what point? Up to 0. As it moves to positive 1, the value greatest integer greater than or equal to my 0.1 is 1. So basically I need to find whether x is in between greater than -1 and less than equal to 0, right? Now with this information I will move to statement 1. Statement 1 tells me that x is greater than -1 and less than -0.1, right? Now it follows that from this that now what does this inequality mean? This means that x has to be greater than -0.1 but not equal to. So we have found that if it is equal to -1, the value is -1. But the inequality says that it is greater than -1. So I can have value this, which gives me 0. And for 0.1 we have also calculated it to be 0. So that means in this range x is equal to 0. So I can definitely say that this operation under this, so this is equal to 0. So I can say that yes, x is equal to 0 with this operation. So I will say that statement A is sufficient to answer my question. If you want, we can take some examples in this range. Let us suppose it to be -0.5, right? So this will be equal to 0, right? So since we have calculated the range and it falls inside this range, so we can definitely say that x is equal to 0 and A is sufficient to answer my statement 1 is sufficient. Now moving to statement 2. Statement 2 tells me that x plus 0.5 with this operation is equal to 1, right? So what does that basically mean? This means that this inequality, since it is giving the answer 1, right? So that means all these values will be, the greatest integer for that will be 1. So I can write that x plus 0.5 is greater than 0 and less than equal to 1, right? Now if I shift 0.5 or subtracting -0.5 from all these inequalities, I will get over here -0.5 greater than x and less than equal to 0.5, right? Now if I take some values, now if I draw it on the number system, so it will be like this. Here it is 0, so it is basically from this point -0.5 to +0.5, where this value is not included and this value is included, right? Now in this range between -0.5 to 0, let us suppose I take an example of -0.4, right? So for this particular value I will be getting it the answer as 0, right? But as I shift from 0 to 0.5, let us suppose I take a value 0.4. Now for this the greatest integer will be 1. So I'm getting this answer as 0 or 1 also, because for this between this the greater integer will be 1, right? So we can't determine the value of x and we can't definitely say whether it is equal to 0 or equal to 1, because since we have found the range for x with this, so we will say that statement B is not sufficient to answer my question. So for this particular question I can say that statement 1 alone is sufficient to answer the question. The circular base of an above ground swimming pool lies in a level yard and touches two straight sides of a fence at points A and B as shown in the figure above. So this is a circular swimming ground and these two fences A and B touch it at A and B from C. Point C is on the ground where the two sides of the fence meet. How far from the center of the pool's base is point A? So we need to find. So let us first draw the figure. So this is a circular swimming pool and here it is a point C. And from here, if I draw two tangents, so this is C, this is B, and this is A, right? Now, this is the radius O. So here, what we need to find is how far from the center of the pool's base. So center is O, let us suppose it to be O, is point A. So we need to find basically this. And this is also the circle of the radius of this circle. So let us suppose OA to be R, and we need to find the value of R, right? Now with this information, moving to statement 1. Now statement 1 says the base has area 250 square feet. Now we have been given the area of this to be 250 square feet, and we know that area of circle is equal to pi r square equal to 250. So from here I can find the value of r, right? So r will be equal to 250 divided by pi under root So I can say that statement 1 is sufficient to answer my question alone. Now moving to statement 2. Statement 2 tells me that the center of the base is 20 feet from point C. So this is 20 feet, right? Now we know that the tangent drawn from an external point to the circle is perpendicular to the radius. So this angle is 90 degree, right? Now with this information I can't find the value of R, or I can write this as OA square plus AC square is equal to OC square, which is equal to 20 square. So only thing I can extract is OA square plus AC square is equal to 400. So I can say that statement B is not sufficient to answer my question. So for this particular question, we'll mark option A, statement 1 alone, to be sufficient to answer this question. If x into y is equal to minus 6, so xy is equal to minus 6, what is the value of xy multiplied by x plus y? So we have been given xy equal to minus 6 and we need to find the value of xy multiplied by x plus y. So putting this value over here, I will get minus 6 into x plus y. So basically I need to find x plus y, or the individual values of x and y, right? Now with this information we will move to statement 1. Statement 1 tells me x minus y is equal to 5. Now since x minus y is equal to 5, I can have different values for this, and product has to be minus 6. So if I assume x to be equal to, so this implies that x is equal to 5 plus y, right? Now since xy is equal to minus 6, so I can put this value over here. So I will be getting 5 plus y multiplied by y equal to minus 6. So this further implies 5y plus y square is equal to minus 6, or we get a quadratic equation y square plus 5y plus 6 equal to 0. Now since the product is 6 and sum is 5, so I can write this as y square plus 3y plus 2y plus 6 equal to 0. 3y plus 2y is 5y. So I will be taking y common. So here I will be left with y plus 3 plus 2 y plus 3 is equal to 0. So this implies y plus 2 y plus 3 equal to 0. So I will be getting value of y equal to minus 2 or minus 3. So I am getting two values for y. Now since x minus y is equal to, so putting both the values, so if y is equal to minus 2, then x minus of 2 is equal to 5, or I can say x is equal to 5 and this is plus 2, so 5 minus 2, so this implies x is equal to 3, right? Now if I put the value of y to be minus 3, now in that case it will be x minus of 3 equal to 5, or I can say x is equal to 5 minus 3 equal to 2. So x is coming out equal to 2 when I am getting y equal to minus 3, right? So I am getting two values for y, and when y is equal to minus 2, x is equal to 3. So x plus y in this case will be equal to 3 minus 2, which is equal to 1. And in this case x plus y is equal to 2 minus 3, which is equal to minus 1. So for this particular value I would be getting minus 6 multiplied by 1 as my answer, minus 6, or minus 6 multiplied by minus 1, which is equal to 6. So minus 6 and 6 are the values which are coming out for xy, x plus y. So since I am getting two values, I will say that statement A is not sufficient to answer my question, right? As I am not getting a single value for the xy multiplied by x plus y. Now moving to statement 2. Statement 2 tells me that xy square is equal to 18. Now I can write this as xy multiplied by y equal to 18, right? Now I know the value of xy, which is minus 6, so I will put that value in place of xy, so equal to 18. So this implies y is equal to 18 divided by minus 6, which is equal to minus 3, right? Now if I am getting y equal to minus 3 and I know that xy is equal to minus 6, so putting the value over here, so this will be minus 3 equal to minus 6, minus gets cancelled, I will get the value of x equal to 2. So From this I can get x plus y equal to minus 1, and I will get the value of minus 6 x plus y equal to minus 6 multiplied by minus 6 equal to 6. So I am getting a single value for this. So I will say that statement 2b is alone sufficient to answer my question. So for this particular question, statement B is sufficient to answer my question. If y denotes the greatest integer less than or equal to y, is d less than 1? So we have been given that this means that the greatest integer which is less than or equal to y, right? We need to find that is d less than 1 or not, right? Now, with this information, we will move to statement 1. Statement 1 tells me that d is equal to y minus this operation on y, right? Now, we can have two different scenarios. One is if y is an integer, right? And another is when y is non-integer. Now, if y is an integer, let us suppose the value of y to be 1. So in that case, this operation y will also be equal to 1, because this means that greatest integer less than or equal to y. So equal to y, right? So in this case, d will be equal to y minus y, which is equal to y 1 minus 1 equal to 0. And in this case, d is less than 1, and we will say yes, d is less than 1 in case of integers. Now, let us suppose some non-integral value for this. Now, let us suppose y to be equal to 0.3, right? Now, if y is equal to 0.3, then if I apply this operation and according to this definition, y is greatest integer less than or equal to y. So what is the greatest integer which is less than this? So that will be equal to 0, right? And now y minus y operation will be equal to 0.3 minus 0, which is equal to 0.3, and again I am getting d is less than 1, right? Now, if we draw a number line, now let us suppose another value for this, y equal to minus 0.9. Now, for number line, the greatest integer which is less than this. So greatest integer, now operation, when I apply this operation, the greatest integer, there are only two integers in between near to this. One is minus 1 and one is 0, right? Now, which is less than this is minus 1, right? And greater than this, so I will say that the value is minus 1. Now, minus 0.9 minus of 1, so that will be minus of 1, so that will be equal to minus 0.9 plus 1, so that will be equal to 0.1. So again d is equal less than 1, right? So how is this happening? Basically is that, let us suppose this is 0 and we draw a number line minus 1, 1, 2, 3. If the point is lying over here, right, the greatest integer which will be less than this will be 0, right? And the distance will be always be less than 1. Now let us suppose we try to find some integer, non-integer over here. So the greatest integer which will be less than this will be 1, and particular value will be this, so the distance will always be less than 1 units. So that's why we are getting this always equal to less than 1. So we will say that statement 1 alone is sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that this operation d is equal to 0. Now what does that mean? This means basically that in what scenarios d can be equal to 0? Only when d is less than 1 and greater than equal to 0. So I can write d to be greater than equal to 0 and less than equal to 1. Right? Because if the value is 0, again that will be equal to 0. But if it is equal to 0.9, it will be equal to 0. But if it is equal to 1, so then it will be 1. So we have to write down, that's why I have not written equal to over here. So this basically means that d has to be less than 1. So again I can say that statement B is alone sufficient to answer my question. So in this particular case I will say that statement D, that both the statements alone are sufficient to answer my question. if n is a positive odd integer, so we have been given that n is a positive odd integer. So what can be the values of n? So that could be 1, 3, 5, 7, 9, so on. Now we need to find whether is n prime. So prime means that whether n has only two factors, 1 and n itself. Now with this information we will move to statement 1. Statement 1 tells me that n is equal to 2 raised to power k plus 1 for some positive integer. So k is some positive integer, right? Now we'll put some values for this. Now let us suppose k is equal to 1, right? Now the value of n will be equal to 2 raised to power 1 plus 1, which is equal to 3. And we can say that yes, n is prime because 3 is a prime number. Now let us check for some other value. Let us suppose k to be 3. So n will be equal to 2 raised to power 3 plus 1, which is equal to 8 plus 1, 9. And this is not prime. So we are getting may or may not be condition. So I can say that statement A alone is not sufficient to answer my question. Right? Now moving to statement 2. Statement 2 tells me that n plus 2 and n plus 4 are both prime. Right? So we will check the value for this. Now let us suppose n to be equal to 3. Right? If n is equal to 3, now n plus 2 is 5 and n plus 4 is 7. Now both these are prime, and this is also coming out to be prime. So I can say that yes, n is prime. Right? Now we will find some other scenarios in which n plus 2 and n plus 4 has to be prime. So now let us suppose n to be equal to 9. Now n plus 2 is equal to 11, which is prime. So this is prime, this is prime, this is prime, and n plus 4, which is equal to 13, is also prime. But you see, n is not prime. This is prime, but this is not prime. So I am getting yes as well as no, may or may not be condition. So I will say that statement B alone is also not sufficient to answer my question, which further means that statement D is also not sufficient. So now I will check for statement C, that combining first and 2. Now first give me that n is equal to 2 raised to power k plus 1 for some value k is equal to positive integer, and second gives me n plus 2 and n plus 4 are both prime. So if I put these values in terms of 2k plus 1, so I would be getting this value. So 2k plus 1, basically for this I will have k equal to 2. Fine. So we have seen that in this case also we are getting two values, the answers yes or no. So we can say that statement C is also not sufficient to answer this question. So for this particular question we will say that both the statements are not sufficient to answer the question, and right option will be option number E. So if m is positive integer, so m is a positive integer, right? Then m cube has how many digits? So we need to find how many digits m cube have, how many digits. Now let us consider some scenarios for this. Now moving to statement 1 directly. We move to statement 1 directly. Now statement 1 tells me that m has 3 digits. Now we will try to calculate with some examples. Now let us suppose m is equal to 100, right? So these are 3 digits. So this is a 3-digit number, right? Now what is m cube equal to? M cube is equal to 1, right? So this has 7 digits, so m cube has 7 digits, right? Now let us suppose some other number too for this. Let us suppose m equal to 300. This is also a 3-digit number. So m cube will be equal to 27 and then followed by 1, 2, 3, 4, 5, 6. So it is having 8 digits. So we can't be sure from statement 1 that how many digits m cube can have. M cube can have 7 digits, m cube can have 8 digits, by getting two different examples for m. So I can say that statement 1 alone is not sufficient to answer my question, right? Now moving to statement 2. Statement 2 tells me that m square has 5 digits, right? Now we'll assume some examples for this. Now let us suppose m again equal to 100. So what is m square? M square is equal to 1 followed by 4 zeros. So this is basically 5 digits, right? So statement 2 is being fulfilled, that m square has 5 digits. Now what is m cube? M cube we have originally found, and it has 7 digits, right? But again we'll assume m equal to 300. Same example which we have assumed above. So m square will be equal to 9 followed by 4 zeros. So it has 5 digits too. But we have seen that m cube has 8 digits. So again we have finding that m square has 5 digits, even though m cube doesn't have fixed number of digits. So we can say that statement B alone is also not sufficient to answer our question. So this means that statement D is also not sufficient to answer our question. Now, combining statements 1 and 2, since we have used same examples for both of these and we are getting different digits, so we can say that statement C is also not sufficient. So for this particular question, we will say that statement E, both the statements are not sufficient to give us a particular value of how many digits m cube have. What is the value of x square minus y square? So we have been directly asked this question. So x square minus y square we need to find, or I can say this is a square minus b square, so a plus b into a minus b. So if we get the value of x plus y into x minus y, or x and y, right? Or in simple words I can say we need to find the value of x and y. Now with this information we will move to statement first. Statement first tells me that x minus y whole square is equal to 9. Now what does that mean? This means basically if I shift square to this side, I would be getting x minus y is equal to under root of 9 plus minus. So this implies x minus y is equal to plus 3, or x minus y is equal to minus 3. Right? Now, still we don't know anything about x plus y, right? We can assume some examples for this. Now let us suppose x to be equal to 9 and y to be equal to 6. So 9 minus 6 is equal to 3, right? But if so, that means x plus y, so this is x minus y, and x plus y will be equal to 15. So 15 into 3 is 45, right? But if I assume the value of x square, x equal to 7 and y equal to 4, so I would be getting x minus y is equal to 3 and x plus y equal to 11. So the product will be equal to 33. So we're getting two different values. So we can say that statement A, we can have some non-integral values as it also, because we are not given that x is both are integers. So we can say that statement A is alone not sufficient to answer the question. Now moving to statement 2. Statement 2 tells me that x plus y is equal to 6. Now again I don't know anything about x minus y, right? We can have some examples for this also. So we will say that statement B is also not sufficient to answer my question, which means statement D is also not sufficient. So now moving to statement C, which tells combining statement 1 and 2. Now combining, I get x minus y equal to 3 and x plus y equal to 6. And here I am getting x minus y equal to minus 3, because we are getting two values for x minus y, and x plus y equal to 6. Now adding this I get 2x is equal to 9 and x is equal to 9 by 2, right? Now if x is equal to 9 by 2, then 9 by 2 minus y is equal to 3, or I can say y is equal to 9 by 2 minus 3, which is equal to 9 minus 6 divided by 2, which is equal to 3 by 2. So y is equal to 3 by 2. So x square minus y square will be equal to, or you can just calculate by x plus y into x minus y. So that will be 81 by 4 minus 9 by 4. So this is equal to 4. So 81 minus 9 is 72. So this will be equal to 36 by 2 equal to 18. Right? So I'm getting x square minus y square is equal to 18. Now let us find we get the same value from this. Now if I add this, I get 2x equal to 3. So x is equal to 3 by 2. So putting this value over here, I would be getting 3 by 2 minus y equal to minus 3, or y is equal to 3 by 2 plus 3. So this is basically 9 by 2. So x is 3 by 2 and y is 9 by 2. So x square minus y square becomes 9 by 4 minus 81 by 4. So this is minus 72 by 4. So I'm getting the value minus 18. So by combining the statements also, I'm getting the two values for x square and minus y square. So what we will do? So for this particular question, the right option will be statement E, that both the statements are still not sufficient to answer the question. Thank you for today's lecture. Bye bye. Take care. If you want some video on specific topic, you can comment me, and if you find some error, please do comment so that I can rectify it. Thank you. Bye bye. Take care.